Okay, so boys and girls, we're still talking about forces. And we're going to be looking at a video that has some cars in it. But first, let's read what it has to say about cars and forces that are involved in cars. This is called Funny Car Forces, and we're on page 92. So a powerful force from the engine pushes these cars down the track. The cars move so fast that the brakes alone can't stop them. So that they're moving so fast that even if you press on the brakes, it's not going to stop them. Can you imagine? Because when you're driving in a car, you're not moving so fast that the brakes won't stop them, because your mom or your dad or who's ever driving, they press the brake and the car will stop, right, boys and girls? Now, to stop the motion before the cars run off the end of the track, another force needs to act on the cars too. So they have another force that's going to help stop the cars. So we're going to watch the video to discover more about forces. So let's watch the video.
Watch the video to discover more about forces.
Forces acting on a car change from balanced to unbalanced when the car is speeding up, slowing down, or turning. When a car is motionless, forces are balanced.
Did you see that? Yep. What helped the car to stop? Should I do it one more time so you can watch it again? Because those videos go so fast.
Forces acting on a car change from balanced to unbalanced when the car is speeding up, slowing down, or turning. When a car is motionless, forces acting on a car change.
Let's see.
Oh, looks like it broke.
Did you see what it was?
Yeah, a little bit.
Forces acting on a car change from balanced to unbalanced when the car is speeding up, slowing down, or turning. When a car is motionless, forces are balanced.
There it goes.
I saw it.
Did you see it that time?
Yeah.
Okay. I know the videos go so fast that it's kind of hard to see what's happening.
I thought like it turned on its side.
Okay. So what did you see that happened to help stop the car? What did they use? Rose? They used a parachute. That's the force they needed to stop the car because they're going so fast. Has anybody ever seen car races that are like that? Yeah, those are like these, they have special cars that they're like drag racers. Have you seen that? Is it pretty cool when they do that? So the tracks are really short. They're not very long tracks, and the cars are going very, very fast. And in order for them to stop, they have to have the parachutes to provide like enough drag to stop the car. So boys and girls, so let's try to figure out what is happening in that video. So I'm going to scroll this up. Now you have it in your book. You have a picture. I think your picture might be, yeah, you have the same picture. But you don't have, you have a place to write. So this is what I want you to start writing in your book. It's asking us. You have a question. It says, look at the pictures below. Doesn't it say that? Describe how the forces acting on the car change from balanced to unbalanced or vice versa. So when the car is moving, so the engines are creating a force, right, boys and girls, that is making each car move forward. That's what's happening. Are the forces balanced or unbalanced when the car is moving? Lucas? Unbalanced, because the motion of cars is changing, correct? Now, how can we tell when the forces become balanced? How do we know when the forces become balanced? Yes? When the parachute comes out. When the parachute comes out, and then what happens? Bianca? The car is not moving anymore. That's right. The motion of the car stops changing. The motion is not changing anymore. So let's look here. It says, Use your understanding of the topic to complete the following statements. This car goes from not moving to moving very quickly. So this is what we're going to say. We're going to write this in our book to explain what's going on with the car. So I want you to write, when the car is stopped, everybody write that, when the car is stopped, the forces are. So we're going to say when the car is stopped, the forces are. And now, boys and girls, we're going to have to decide what the forces are doing. Are the forces balanced or unbalanced when the car is stopped? And we're not going to write anything till we check. Bianca? Okay, we're going to pick that and we're going to see. Pushing the gas makes them what? Balanced or unbalanced? Gabe? Unbalanced. Let's see if you're right. Yes. So we're going to continue to write. So we already have, when the car is stopped, the forces are balanced. Did everybody write that? When the car is stopped, the forces are balanced. Pushing the gas makes them unbalanced. You don't have balanced forces anymore. Things are no longer balanced. Yes?
Do we have to write that part?
Yes, write that part. That's an important part as well. So that's all in our first picture. That's explaining what's going on. Okay, you're writing, yeah, you put a period there. And then write, pushing the gas makes them unbalanced. You might have to write in the white. We don't have very much room there. So boys and girls, when there is no motion, the forces are balanced. Remember, we have forces coming from both sides, so it's all balanced. When the car begins to move due to pushing the gas pedal, the forces are unbalanced. Remember when we were looking at the pictures of the dogs? And we had dogs pulling on the pull toy, and we had balanced and unbalanced forces. And then we looked at the dog pulling against the horse. Those were unbalanced. So here, when that car is moving, we have unbalanced forces when it is moving. Okay, did everybody get that written down? Now we're going to continue. So now we're looking at our second picture. And this is our parachute. Now we got a good look at that parachute. Doesn't that look cool, boys and girls? I like how that looks. A parachute rapidly slows the car down. How do the forces change as the brakes and parachute bring the car to a stop? So what is happening now? So the parachute deploys. So what happens? Is the car going from balanced to unbalanced? Is it going from unbalanced to balanced? Or is there no change in forces? What is happening here? Ava?
Unbalanced to balance?
Well, let's see. Yes, very, very good. When the parachute pulls on the car, it begins to slow it down, right? It's going to begin to slow it down. The car will eventually stop when the forces, where the forces will again be balanced. So here's what we're going to write. We're going to write the forces. I'm going to, you know what I'm going to do this time? I'm going to write it for you. So let me write what we're going to write. That'll help us, because we're going to write something a little bit different here. We are going to write on the car. Go from unbalanced to balanced because the brakes and parachute bring it to a stop. Okay, so they're bringing it to a stop. So they're making it balanced again. So we have the parachute and the brakes, and they're bringing the car to a stop. Okay, does everyone have that written down? Very good, very good. Now, let's look at our next thing we're going to think about. I'm going to pull this up. Now we're going to have to use some of our math skills. And it's called strong pull. It says you can use math symbols to show balanced and unbalanced forces. And you have got a picture on your page, and I've got a video to go with it. It says you can use math symbols to show balanced and unbalanced forces. There are 6 horses on this team. It takes a force of 80 or greater to move the farmer on the plow. Okay, so it takes a force of 80 or greater to move the farmer on the plow. So we're going to see if he's going to move.
All motion is caused by forces. Forces are pushes and pulls. These horses use their muscles to push against the ground as they take steps to move forward. The horses apply a pull on their harnesses, causing the plow and the farmer to move along with them. The plow blade pushes into the earth, moving the soil.
Okay. Did you see it? Do you want to see it again?
Yeah.
Okay, we'll watch it one more time.
All motion is caused by forces. Forces are pushes and pulls. These horses use their muscles to push against the ground as they take steps to move forward.
Can you see it?
The horses apply a pull on their harnesses,
Can you
causing the plow and the farmer to move
Can
along
you
with
see
them.
it plowing up the ground?
The plow blade pushes into the earth, moving the
Okay, did you see the plow blades plowing up the earth? That's how they always used to plow. They didn't always have the big machines that farmers use now. Yes, Hector?
And the guy who's on there, he looks like he's trying to stop the horses.
Well, he's not trying to stop them, he's just steering the horses along. That is, he's a farmer steering the horses along. Oh, so now here's what we're going to do. We're gonna think about these horses and the farmer and the forces that they're using. So, think about this. Now, how many horses are there? How many horses are there, Bianca? 6. Now it takes a force of 80 or greater to move the farmer on the plow. 80 or greater to move the farmer on the plow. Now, think about what was going on in the video. Is the combined pulling force of all the horses greater than, less than, or equal to 80? What do you think? So it takes a force of 80 or greater to move the farmer on the plow. So do you think the combined pulling force of all the horses was greater than, less than, or equal to 80? Do you think it is? What do you think? Bianca? It could be equal. Yes, what do you think? Logan? Could be equal, yes. Rosie? Could be equal, yes.
Greater than.
It could be greater than, yes.
Greater than.
Could be greater than, yes.
Greater than.
It could be greater than 80, yes. It could be equal to, yes.
I'll say greater.
Okay, you're right. It could be equal than or greater than 80. We don't know. It could be equal than or greater than 80. We know it's not less than. How do we know it's not less than? How do we know it's not less than 80? Evelyn?
Because horses are strong and they can push with more force.
Oh, well, okay, horses are strong, but there's a specific reason why we know for sure that this was greater than or equal to 80. What's the reason we know? Not just because horses are strong. Why do we know for sure? Bianca?
Because it wouldn't be moving.
It wouldn't move the plow and the farmer, right? Because we saw it was moving the plow and the farmer. So we know for sure it was greater than or equal to. Okay? So here, that is not helpful to us. So let's write on our page for your answer. I don't really like that answer for that. So the combined force for question A, we're going to say the combined force of the horses is equal or greater than 80. Okay, so that is A. We know that much. Did you write that already, Bryson?
Yep.
Awesome. You write faster than I do. So that much we were able to figure out for sure right now. That's good thinking, boys and girls. Because we saw with our own eyes that the horses were pulling the farmer and they were plowing the field. And we knew how much force it took to do that. We knew. They told us. Okay? Did everybody write that? Yes? Okay. Now let's move to our next question. Now we wanted to know, what is the pulling force of a single horse? Now, is the pulling force of a single horse greater than 10, less than 10, or equal to 10? What do we think it is? What do you think?
Greater.
Greater than 10. You are correct. And why do you think that? Bryson, why is it greater than 10?
There's only 6 horses.
That's right, because there's only 6 horses and it has to be 80 or greater, right? The pulling force of one horse must be greater than 10. Okay, and now we have to see who can figure out the next one. It says, write a math sentence to show balanced forces for a team of 4 horses that cannot move the farmer and plow. So now what do you think? Let's say we cannot move the farmer and the plow, but they are all balanced. Can anybody give me a math sentence where we cannot move? And it's got to be balanced. Yes?
40 plus 40?
No, there's, how many horses are there?
60.
Well, 4 horses, so we need it for 4 horses. And it's gotta be, have to equal less than 80. For 4 horses, and it has to be balanced. Yes?
20 plus 20?
That's only 2 horses. Help me out here, Logan.
15 plus 50?
For 4 horses, 15 plus 15 plus,
50.
yes, for 4 times. So 15 plus 15 plus 15 plus 15, and what does that equal? 15 plus 15 is 30,
60.
60. So that would make, they could not move the farmer and the plow, those 4 horses.
Okay.
Oh, thank you. We're figuring out horsepower, pulling horses, or they're pulling a farmer. Very good. Thank you, boys and girls. You did a good job figuring that out. It was tricky business.